In this video, we're going to talk about how to recognize, work with, and solve linear equations. And before we get too specific, recall that an equation in general is arrived at when we want to understand when two expressions are equal to one another. And so the general mathematical form that any equation will take is that of two expressions with an equal sign in between them. And what it will mean to solve an equation, again, keeping things very general here, is to understand the precise conditions under which the expression on the left is in fact equal to the expression on the right. Getting more concrete now, recall that a linear expression is any mathematical expression that has the form ax plus b, where a and b are constants, and where we will assume that the constant a, the coefficient of x, is non-zero. If a is equal to 0, then of course the expression would just be equal to a constant, which we'd like to avoid. And a linear expression has no equal sign within it. A linear equation, on the other hand, is any equation that can be put into the special form ax plus b equals 0, where once again we assume that a, the coefficient of x, is non-zero. So a linear equation, in other words, is any equation that can be arrived at by taking a linear expression and setting it equal to 0. And it's a very basic but very important kind of equation in mathematics. So let's look at an example. What we're looking at here is clearly an equation, right? It's two expressions with an equal sign in between them. And although it doesn't have the form ax plus b equals 0, with a little bit of work, we can actually put it into that form. And we might begin here simply by taking the two terms that involve x in the left-hand side and combining them. So the left-hand side of the equation can be written as 1, and now we're going to want to add the coefficients of x together. That's minus 1/2 and 4, giving us 7/2 times x. And that will continue to be equal, of course, to the right-hand side, which is 2/3 x plus 7. Next, notice that one can always manipulate an equation as long as one adds or subtracts the same quantity to both sides. So what we can do here is take the term 2/3 x that appears on the right and subtract it from both sides of the equation. That will eliminate it from the right-hand side and give us, on the left-hand side, 1 plus 7/2 x minus 2/3 x, and this will now be equal to just 7. Combining the x terms on the left-hand side by finding a common denominator now gives us 1 plus 17 over 6x, which is still equal to 7. And then, to finish things off, I can subtract 7 from both sides of the equation. And after rearranging the terms on the left-hand side just a little bit, we arrive at the equation 17 over 6x minus 6 equals 0. And this is indeed the form of a linear equation by our definition. So what we've done here is show that our original equation is indeed a linear equation because it can be put into the standard form ax plus b equals 0. And in general, it's not hard to recognize a linear equation. An equation will be linear if the terms on the left and right-hand side are simply additive constants or constant multiples of x. Let's quickly think about how to solve a linear equation in general. What we want to do to solve an equation is find all values of x that make the equation true. Remember that a and b are fixed constants here, and x is the so-called variable. And we'd like to determine once again which value of x will make the equation true. Well, if the equation is in standard form, ax plus b equals 0, then we can of course proceed in just a couple steps by subtracting b from both sides of the equation, and then by dividing both sides of the equation by a. And note that this is possible because we are assuming that a is non-zero. So the general solution here will be x equals minus b over a. That's the general solution of an arbitrary linear equation. So to return to our previous example, if we wanted to solve this particular linear equation, we can now quickly see that the solution will have to be minus 6 divided by 17 over 6, and that works out to be 36 over 17. So this number, in other words, is the value of x, which, when substituted into the equation, makes the two sides of the equation equal to each other. Linear equations often arise in real life, so let's finish up by considering a simple word problem. This problem says that a tree that is 8 feet tall, growing at a rate of 3.5 feet per year. And the question is, in how many years will the tree be 50 feet tall? This problem is indeed asking us to solve an equation. It's asking us to determine when the height of the tree will equal the value 50. Now let's think about how we can express the height of the tree. The problem tells us that the tree is initially 8 feet tall, and that for every year that goes by, its height increases by 3.5 feet. Well, that means that the height of the tree will be modeled by the linear expression 8 plus 3.5. Let's use the variable t to stand for time. Okay, so t will be measured in years here. And once again, for every year that goes by, the height of the tree increases by 3.5, and it's initially 8 feet tall. So there is a linear equation hiding behind this problem. To solve this equation, we know what to do. Let's begin by subtracting 8 from both sides. That's going to give us 3.5t equals 50 minus 8, or 42. And now, by dividing both sides by 3.5, we obtain the value t equals 42 divided by 3.5. And that works out to be precisely 12 years. So in 12 years, the tree will be 50 feet tall. And this is an answer that I think is rather difficult to guess. But by setting up an appropriate linear equation and proceeding systematically, we're able to arrive at the answer in a very straightforward way.